Hey, good morning, everybody, or afternoon. This is a quick lesson on similarity. It's the first section on chapter 8. So similarity is going to talk about things that have maybe a different size but same shape. That's the idea, and it all sets us up for this thing called trigonometry. Huge deal. So as you can see, we got a picture. We got Carlos. He's standing there. Um, we got the American flag waving bravely. And with the information given, you might have a shot at figuring out the height or the value of x. Of course, there's always seems to be an x in all these math problems. Couldn't use a different variable, but um, there it is. So our goal today is to figure out why we can and how we would do it. So we'll come back to this problem a little bit. All right, similar figures. So of course, I have geared this class towards building the house, and at some point in your life, hopefully you do build a house, and what we use are these house plans, and they are similar to what happens on the house, but obviously you can't have plans that are as big as the house. So right away, we have something that we can kind of tap into and say, yeah, so plans are all about similar figures. So if this was our particular layout, it all has the dimensions and all that, and everything's kind of relationally correct. All right. So once again, I'm tapping into the idea that I really do believe that you kind of already know what similarity is. So there's Mama Bear. You could kind of think about which ones do you think are similar to Mama Bear? Well, and this is, of course, if we were live, we'd be all voting and yelling and screaming and having fun. Uh, this one doesn't work too well. It's stretched out in one dimension, so I'm not too sure about that one. This one is kind of like stretched vertically. I mean, there's nothing wrong with that. But boy, three seems to have like gotten wider and taller, and certainly two looks pretty good. So if you were leaning towards two and three, you were definitely in the running for kind of understanding intuitively what similarity is. All right, so there are two ways to find if two shapes are similar to each other, and that is simply, boom, we get rid of that. Uh, if you can just show that the angles are all equal, that is all you need in order to say that two shapes, or two triangles, I should say. Yeah, gotta say two triangles. I don't want to get too crazy um, with saying just yeah. So let's stick with two triangles, and then obviously we could look at just the side lengths and show that they're proportional. So what does that mean? Well, in this case, we have, if we look at those two triangles, we can see that angle A is equal to or congruent to angle X. We have angle B is congruent to angle Y. And since two angles of one triangle are equal to two angles of another triangle, you know all three. So that's really all you need to do, and there's a shortcut method, and that's the AA theorem, and that's really the next couple sections. It's not really what I'm pushing, but it's something that you can kind of connect to right now. In a triangle, that's all you need to show. So it doesn't work for congruent triangles, but it definitely works for similar triangles. When we say that the sides are proportional, what we're saying here is if I take two sides off of this triangle and compare it to the corresponding sides on the other triangle, do we get the same thing? So let's take the shortest and the longest of this side. So 10 over 14. So the question is, does that equal the shortest over the longest here? 5 over 7. And sometimes you'll be able to see it. The numbers will just be like popping for you and you'll be good. Sometimes you just plug it into your calculator and see if you get the same decimal. This, I hopefully you can see, boils down to 5 over 7. So that is definitely the same as that. So we'd say that they are proportional. Um, and then we could check the other side. Not the emphasis of this particular chapter. So if it's like, what? What did he say? Say what you need to notice is when we look at the lengths of the sides, they all kind of work together. All right, so for right now, that's going to be good enough. All right, little demo. So here are two triangles that are certainly the same. They are congruent, but when we just do this, all the angles still stay the same, but now the lengths are proportional to each other. And proportion is when we set one ratio equal to the next ratio. So that's pretty cool. We can make it bigger, and still the angles are going to stay the same. All right. It doesn't have to be triangles. It can be odd shapes like this. Those two shapes are definitely congruent the way they are. All the angles and all the sides are equal. But if we just kind of mess with it a little bit, we still get a shape with all equal angles. But now maybe these sides are maybe twice as big. And and what's cool about proportionality is if this side and this side are corresponding and one's twice as big as the other, then all of the sides are twice as big. So that's the power. That's the power. So in that twice as big statement, we get this thing called the scale factor. All right, so it's like, how much bigger is it? Well, it's pretty obvious to see that if we start with this triangle and we multiply all the side lengths by k, then our new side lengths are going to be k times a, k times c, k times b. All right, so the scale factor is what you're multiplying those sides by. So it's not going to be that apparent, like what is the scale factor? So um, all you really have to do is take two corresponding sides and divide them. And what you get is the scale factor. So if I take this length right here, KA, and I take its corresponding length, A, the A's cancel, I'll get the scale factor. I will produce what I'm multiplying all the sides by. And you're like, well, no kidding, Mr. Sayers, that's what we said we were multiplying by. But when we're working with numbers, sometimes it's not so easy to see what K is. Let's do an example. All right, before we do an example, we'll talk about, I think this is on your worksheet, so it kind of says, hey, are you able to identify what corresponds to what? So angle A, angle B, and angle C all correspond to something in that other triangle. And all you have to do is match up the angle measures. So this would be angle X, angle Y, and angle Z. Now I'm not paying attention to location. Well, that helps a little bit, but I am really focusing on what are equal to what, because one might be a flip of the other one. So it's really important to match up that. All right, so once we know, we kind of have that orientation, we could say that side AB, so when I'm looking at side AB, I'm looking at the single one there and the double. So where am I going to go from the single to the double here? And that's obviously X to Y. There are three sides of a triangle, so there are going to be three pairs of corresponding sides. So we go AB, go BC. So BC goes to YZ. And then the last side length here is AC or CA, doesn't matter. And that goes to XC. Simple. So identifying corresponding sides, very important. All right, so here we are. I believe this might be an example on the worksheet that I gave you for the guided notes. We know, okay, so this is a similarity statement. This symbol right here is similar to. And order is extremely important in a similarity statement. That means angle A matches up to angle E. Angle B matches up to angle F. Okay, side CD matches up with, oh, let's change colors there. Side CD is going to match up with side GH. So When you have a similarity statement, it's actually easier to work off of than the picture because the picture might be flipped around, backwards, whatever. So you can always trust. So let's do that. Angle E right here is the first letter here, so it has to go with measure of angle A. Angle B is the second letter here, so that has to go with the second letter here, measure of angle F. Notice I'm not even looking at the pictures. Now I can glance at the pictures and make sure I'm doing this right, but it looks good. So AB over EF, great. Hopefully they've written that as corresponding sides. So we go over here, AD. Now notice here's the letter A and here's the letter D. So that means I go the first letter here and the last letter here, EH. Now I'm going to take a look and just make sure. So here's AD and here's EF. And that sure makes a lot of sense. They're the ones. Life's pretty good. So I come down to the last one, FG. FG starts from here to here. And since these are kind of oriented the same, I'm going to go B to C. And, real quick, if I want to check that, FG is this letter to this letter, and I said it was this letter to this letter. So that works out. So the picture and the similarity statement both tell you a lot of information. All right. So determine if the following figures are similar. Explain. Are they similar? The question, gee. Well, right away, I want to make sure all the angles are the same. That looks good. That looks good. That looks good. That looks good. Whoa, whoa, whoa. Don't fall for it. They kind of look the same, but they definitely are not because all the angles have to be the same. No, not congruent angles. Is there such thing as pretty close to similar? Sure, but it doesn't work very well in our mathematics. So don't give up the, hey, that's close, that's fine. But it is not exactly, and it needs to be exactly for our mathematics to work. All right, so we get in a few little examples here. They are telling you something right here. They are similar. That means all the angles are the same and the sides are in the same proportion. So find the scale factor. All right, so the scale factor is going to be found by any corresponding sides, any corresponding sides. So one way to look at it and go, okay, the longest side will always correspond to the longest side. So the scale factor is always found by the ratio of any two common sides. So if I take 30 over 18, I get K. Beautiful. Well, what is 30 over 18? Well, I can plug it in my calculator. I can do a bunch of things. Looks like they're both even, so maybe I take it 15 over 9. Hey, wait, 3 goes into both of those, so 5 over 3. So 5/3. Now notice what that means. That means if I multiply all the sides by 5/3, I get the lengths of the other side. But look at the direction. 5/3 is greater than 1, so 5/3 is the scale factor that I would need to go from this small to this big. But Mr. Sayers, what if I wanted the scale factor that took me from the bigger to the smaller one? Well, if I want that, it's very simple. If I want to go in this direction, I just flip that fraction. It is 3/5. And 3/5 is less than 1. In other words, it makes things smaller. So if I multiply 20 by 3/5, I will get 12. Let that sink in. The scale factor is a number that takes you from one length to the other length. So if you want to go in the opposite direction, just flip that scale factor. I don't think I really need to list all the pairs of corresponding angles. I think T goes with Z, R goes with X, S goes with Y. All right, so now we're gonna get into some a little bit of manipulation using the idea of similarity to solve for missing values. All right, so this is why we showed up. This is what we're getting the big bucks for. All right, so this is what we're looking for. And we're going to set up a proportion. A proportion. Now, proportion is setting up. proportion. I don't know. Proportion. Yeah. It's setting a ratio equal to a ratio. A ratio equal to a ratio. Well, the ratio of corresponding sides. So I can do this many different ways. I can do x over 15. And what I have to do is be careful to pick the corresponding sides in the right answer or the right order. So that is going to be 30 over 18. All right, so once you've got the proportion, you're going to do the same step every time until you see a shortcut. And when you find a shortcut to this method, great, use it. But every time this will work. It's called cross multiplication. So what we're going to do is we're going to take this 18, we're going to multiply it times that x, and we're going to take this 15, we're going to multiply it times that 30. So it's going to be 18x equals 15 times 30, which is 18x equal to 450, and then divide both sides by 18. 18, and we get 25. I think, let's see, 5, 90, 90, oh, 9, 50 to, yep, 25. Cool. Well, Mr. Sayers, the book does it different. The book does x over 30 because those are corresponding sides, the two longest sides, and then over any other known pair. So maybe I take the 15 over 18. Corresponding, same direction. If I start with the x over 30, I do the 15 over 18. And you're like, Mr. Sayers, see, I got a different thing. But once you cross multiply, you'll end up with the same equation, 15 times 30. So relieve yourself of the stress. Just be consistent. Just be consistent. All right, write a similarity statement, find the scale factor, solve for x. So this is the full meal deal. This is everything we need to do in this section. So let's see if we can do it. All right, all the angles are the same. So we are going to go ahead and, all right, I think I'm in blue. Okay. So the similarity statement, all we do is pick 4 letters on one of the things in any order, and then it really defines what we're going to do on the second part. So let's just say L, M, N, P. So that shape is similar to, now I have to go with what corresponds with L. Since L is the 2 right here, that's the 2. Yep, so we'll go in that order, G, H, J, K. G, H, J, K. It's a powerful statement you're making, so don't mess around. Make sure every angle matches up with every angle. All right, the scale factor. The scale factor is what am I multiplying this by to get this, or vice versa. It doesn't matter. So I'm just going to say the scale factor is, I can pick any 2 corresponding sides. So I don't know, I'll pick the 15, and that's the longest side, so I'll pick the 10. So 15 over 10, or I could have said 10 over 15, doesn't matter. 5 goes in both those 3 halves, 2/3. So which one are you supposed to pick, Mr. Sayers? Well, if they say that takes you from one to the other. So let's say we want the one from LMN, and that's getting smaller. So then I would choose the one that makes things smaller, 2/3. You multiply something by 2/3, it gets smaller. If they wanted the scale factor that took me from here to here, then I would say the scale factor is 3 halves. All right, finally for number 3, solve for x. There's x, so we set up a proportion, x over. Now we can pick one thing on the same side or pick its corresponding piece over here. I'm just going to pick this pair and make it equal to this pair. So everything's corresponding. So x over 15 equals 8 over 10. Okay? Cross multiply. You can draw this, until you get used to it. 10x equals 15 times 8. 10x equals 0,490, and divide by 10 when we get x equal to 9. That's it. That's all there is to it. Should be pretty simple and straightforward now. I'm right at 20, so I think I'll skip to Carlos and see if we can do this problem. Well, we know this angle is equal to this angle because the sun is one spot, so we know that shadow has to be the same. So therefore, the two triangles are congruent because we know two and now three angles, so all the angles are equal. And now that means that the sides are proportional. So that means we can, I'm going to pick this over this and set it equal to this over this because those are corresponding sides. So if I go x over 15 equals 6 over 4.5, cross multiply, 4.5x equals 6 times 15, which is 90. Divide both sides by 4.5, and we get x equal to 20. So in a real life problem, we'd say, hey, the flag is 20 feet tall. Pretty cool. So all of a sudden, we can find the height of something without having to climb up the flagpole and pull a tape measure up with us. Very useful. All right, so your homework is to do just those 5 or 6 problems that are attached. Maybe I can kind of see that the crowd, maybe some of you are already done. Well, good luck. Please have that ready for me on Tuesday. I'll be back, and you guys have a great day.